Okay, here's our model, our computer model, and it's completely finished. I've got all my formulas in here. You can see in cell D6 my objective function, and here are the formulas for my left-hand side constraints. You can see them up in the formula bar, and I'm ready to use Solver to solve this. If you don't, if you haven't, if it's your first time using Solver, Solver ships with every version of Excel, but you need to install it. It's a little different to install it depending on the version you have. I'll post that. But if you go to File, Options, and then down here you'll see add-ins. You're looking for add-ins. It might be a little different way of getting to add-ins. You'll see Solver. Do you see the Solver add-in right here? Click that. Down here under Manage Excel Add-ins, you click Go, and that brings up the add-ins dialog box. Basically, you need to make sure that's checked. I've already done it. And then click OK, and then that will install Solver. So, once Solver's installed, you'll find it under the Data tab. So I click the Data tab, and way on the end, you'll see a group called Analysis, and there's Solver. Before I call Solver up, I always make sure that I click on the target cell or the cell that I have my objective function in. And the only reason for that, when I click Solver, it brings up the Solver dialog box here, and if I've clicked on that, it automatically sets the objective in there. Otherwise, if I didn't, you won't have it in here, and you'll just need to go and click on it to put it in here. So the objective, under set objective, or next to set objective, that's next to set objective, that needs to be the address for your objective function. Then you need to determine, is it a maximize or minimize problem? In this case, we're maximizing profit, so I want to be sure that the radial button for maximize is selected. Otherwise, I would choose minimum. Or maybe I want some specific value. That's sometimes the case. Right now, we're maximizing. By changing variable cells, those are going to be your decision variables. That's what I always put in yellow. So I will select the range. So click in there, and then go select the range of B5 to C5, and it enters in B5 to C5. The dollar signs there, those mean that that's an absolute reference. So it just means it's an absolute reference. Same thing. Now come the constraints. I need to enter in the constraints. So I've told Solver I want to maximize this D6, but here are by changing. So you go in there and you adjust the variable cells until you get the perfect combination that maximizes the objective cell given the constraints. So I have to give Solver the constraints. I'm going to add them. In this case, it gives me this box. I need to give it the left-hand side. That's going to be, for the first constraint, for the pumps constraint, that's going to be D8. And then here's my sign. The author doesn't put signs in there. That's because the Solver doesn't care what sign we have in here. My signs in this model are just the label. But I need to make sure it's the right sign. And then the right-hand side is going to be F8. So D8 on the left-hand side, F8 on the right-hand side. And then I'll click Add, and I can add my next constraint. If they all have the same sign, you can add them together. So in this case, I can add the labor and tubing constraints together. I put the range D9 through D10, make sure the sign's right, and then for the right-hand side, it's going to be the same matching up range, F9 to F10. Then I add my non-negativity. They're also the same sign, so I can add them together. So the range of D11 to D12 on the left-hand side, change the sign. You can see the different options. Integer we'll look at later, and binary. I want greater than or equal to. And the zeros here. F11 through F12, that's the right-hand side. When I'm done, I can click OK. and here are my constraints. Later, sometimes you mess things up. You've got the sign backwards. Usually Solver will give you some weird answer or wrong answer, and you can come back in and you can delete the constraint. Just select it, hit delete, or you can hit change to modify it. Now, here's a checkbox below the constraints. It says make unconstrained variables non-negative. If that's not checked, be sure it's checked. What that does is that takes the place of my non-negativity constraints. That's why I didn't really need those non-negativity constraints in the model, as long as I have that done. I want you to select Simplex LP because this is a linear programming problem. We'll worry about the others later. So LP, Simplex LP. And then hit solve. Solver results, Solver found a solution, and there it is. I'm going to hit OK. Do you see the pound signs? All that means is that it can't fit the solution and display it. So I'm going to go up here and I'm going to widen it. I'll double click and give it the maximum width, and now it can display it. So a bunch of pound signs, that's not an error. It just means it can't display the number. The number's too big. 66,100 is the optimal solution Solver found, and it found it by choosing 122 Aquaspas and 78 Hydroluxes. So that's my ideal solution. And if you'll notice, that matches up with the ideal solution that we figured out by hand graphically in Chapter 2.